Welcome to Learn Mathematics with Moni. Get your books and pen and get ready to learn.
So welcome to the class on trigonometry of right-angled triangles. There are some basic things to know about the trigonometry of right-angled triangle. My regular students are already saying so catua. Yes, you are correct. They are the acronym of the trigonometric ratios that has to do with right-angled triangles. So, ka and toa. This is so, this is ka, and this is toa. Each of them are acronym representing trigonometric ratios. The so means that sine of an angle, let's say sine theta for example, is equals to the opposite over hypotenuse. Sine equals to opposite over hypotenuse. Opposite over hypotenuse. Ka means cosine of theta or any other angle is equals to adjacent over hypotenuse. Then the third, which is toa, the T means tangent of theta or any other angle is equals to the ratio of opposite to adjacent. Opposite over adjacent. And these are the basic that you need to know about the trigonometry of right-angled triangles. Let's take examples. This is an example on trigonometry of right-angled triangle. We are given this right-angled triangle whose sides are 4, 3, and 5. And an angle is depicted for us as angle alpha. And these are the questions we are asked to answer on this problem. The first thing I will do here is to identify the sides of this right-angled triangle. Hypotenuse, opposite, adjacent. Because angle alpha is the consideration we have here, you can see it repeatedly in the question. I'm going to be using it as my reference. The hypotenuse here is the longest side of this right angle triangle, and it is equals to 5. The side facing angle alpha is the opposite of angle alpha. Opposite, something standing opposite you is something facing you, and that is 3. The adjacent is the side on which its seen angle alpha is sitting upon, and that is side 4. So now we are asked to find sine alpha. Sine, I know that sine is opposite over hypotenuse. That is so. Opposite over hypotenuse. My opposite here is 3 and the hypotenuse is 5. That means sine alpha equals to 3 over 5. That is just it, settled. The second question is asking you to find cos alpha. From the trigonometric ratio, ka, cos alpha is adjacent over hypotenuse. Adjacent over hypotenuse. The adjacent here is 4 and the hypotenuse is 5. That means cos alpha equals to 4 over 5. Then the third question here is tan alpha. Tan alpha, that is the trigonometric ratio TOA. Tangent equals to opposite over alpha. Opposite over adjacent. The opposite here is 3 and the adjacent is 4. So that means tan alpha for this problem is equal to 3 over 4. And we have another question asking us to find the value of alpha. You may be asked to find the value of alpha. How do we find that? To find the value of alpha, I can use any of these 3 trigonometric ratio. If this is you answering this problem as a student, you don't have to use all the 3. But for instructional purpose, because I am teaching you, I am going to be using the 3. When I have sine alpha is equal to 3 over 5. 3 over 5, I will convert it to decimal. And that is 0.6. If you don't know how this conversion is done, I advise you check my videos on conversion between fraction and decimals. This means that sine alpha equals to 0.6. For me to get alpha, I'm going to be taking the opposite of sine. The opposite of sine is arcsine. The opposite of sine is arcsine. And arcsine is written as sine raised to power minus 1. So I'm going to be taking arcsine. Take arcsine of both hand sides. Take arcsine of both hand sides. That means I have arcsine of sine alpha equals to arcsine of 0.6. Arcsine cancels out sine and I am left with alpha. Alpha is equal to arcsine 0.6. If you have your scientific calculator, you can punch arcsine on your scientific calculator. For students in senior school, you make use of scientific calculator. You can zoom in on this video for you to see how I punch my arcsine. On the calculator, you have sine, cos, and tan. To punch arcsine, you press shift and sine. On the monitor, you are going to see arcsine. Then you press your 0.6 equals to, and here it is giving me 36.8698. So if I'm taking my answer to the nearest degree, I'm going to say my answer is 37 degrees to the nearest degrees. That means alpha is 37 degrees to the nearest degrees. But for my students in junior school, you are not permitted to use scientific calculator. You won't be allowed to bring it into the exam hall. So what do? You come to the back of your mathematics textbook. At the back of your mathematics textbook, you have sine of angles, cosine of angles, and tangent of angle. You can zoom in on this video to see what I am about to show you. This written inside the table are the signs of angles. So I want to know the angle whose sign is 0.6. I will look inside this table, all these numbers inside the table. I will look for the closest one to 0.6. At this point, I can see at 37 under 0, I can see 0.6018. 37 under 0, I see 0.6018, which sine 37.0 is equal to 0.6018. Sine 37 under 0. 37 under 0, I see 0.6018. And 0.6018, if I'm taking it to one decimal place, is actually approximately 0.6. So I'm going to take this as my alpha. That means alpha is equal to 37 degrees. Let us use the ratio we got for cosine. We got that cos alpha is equal to 4/5. Converting 4/5 into decimal, 4/5 is equal to 0.8. That means cos alpha is equal to 0.8. For senior students, you put it on your calculator. Senior students, take arc cos rather, of both hand sides. So you have arc cos of cos alpha equals to arc cos of 0.8. Cos cancels out arc cos. So you have alpha is equals to arc cos of 0.8. On your scientific calculator, you punch shift. You can zoom in on this video to see what I'm pressing on my calculator. I press shift, then cos. Then the monitor will display arc cos. So arc cos of 0.8 equals to 36.8698 and so on. So if I want to take that to the nearest degree, the nearest whole number, I will be taking 37. That means alpha is equal to 37 degrees to the nearest degree. Like I said earlier, you don't have to use the three of them when you are solving a problem. I am just showing you for instructional purpose that whether you make use of your sine ratio, your cosine ratio, or your tangent ratio, you are expected to get the correct answer. Then for my junior students, you are not expected to bring scientific calculator into any examination at your level. So what you do is check your trigonometry. There is a booklet called the 4-figure table commonly among you students. That is your statistical and trigonometric table. You will not be allowed to bring your textbook into any exam, but that booklet is permitted in any examination. Inside it, you have all this that you have at the back of your textbook. So go to the table of cosines of angles and check for the cosine of angle that is closest to 0.8. You know, you are not following this path. This path is for senior students. You are picking it up from here, my junior students. So check your cosine of angles for the closest to 0.8. So I am checking here. You may zoom in on this video for you to see what I have in the book. So I'm checking in on cosine of angle. I need 0.8. So I'm checking. Okay, I have so many things close to 0.8, but here I have 0.8100, I have 0.8090, I have 0.7986. I also have 0.8007. So I want to take 0.8007 is the closest in my judgment here. 0.8007, and that I can find at 36 under 8. I find that on 36 under 8. That is cos 36.8. 36 under 8, I got 0.8007. 8007 is approximately, when you take it to the one decimal place, this is 0.8, and that is why I pick it as my closest point. And I got 0.8007 on 36 under 8. 36 under 8 on cosines table. This means I can take my alpha as 36.8. And if you are approximating this to the nearest degree, that means alpha is equal to 37 degrees, to the nearest degrees. From the A part of our question, we got that tan alpha is equal to 3/4. Converting 3/4 into decimal is 0.75. That means tan alpha is equal to 0.75. For my senior students, take arctan of both hand sides. That means you have arctan of tan alpha equals to arctan 0.75. Tan and arctan are a word and its opposite. They cancel each other out. So I have alpha is equals to arctan 0.75. Shift tan 0.75. And that is giving me 36 points. Taking my answer to the nearest degree, I'm going to be taking my answer as 37 degrees. I have 36.8698 and so on, like that. 8699 and so on. So to the nearest degree, this is 37 degrees. And for my junior students, to check your trigonometric tables for tangent of angle and search for the tangent of angle that is closest to 0.75. Search for the one that is closer to 0.75 under tangent of angle. So I am searching for mine presently. In my judgment, 36 under 8 gives 0.7481, and 36 under 9. 36 under 9 gave 0.7508. You can use either of them. In fact, you can still make use of your 37 under 0. 37 under 0 gave 0.7536. 0.7536. That is what you get at 37 under 0. You can make use of any of these three. You can make use of any of them. Because if you approximate this to 2 decimal places, it's going to give you, this is approximately 0.75 to 2 decimal places. Approximate this to 2 decimal places is going to give you 0.75. Approximate this to 2 decimal places is going to give you 0.75. So any of the three are correct. So if I'm making use of this, that means I'm saying alpha is equal to 36.8. And 36.8, when you round it off to the nearest whole number, is going to give you 37. If I'm making use of this, I'm going to be using 36.9. And 36.9, take it to the nearest degree, is going to give you 37. And if I'm using this is 37.0, which is actually 37. So using any of the three is giving you alpha as 37 degrees. So the nearest degrees. And that is all I want to say on that example 1. You can see that that example 1 is so large and encompassing. Let's see another example.
You need to pause right now. Go right now and subscribe to my channel. Click on the notification button so that you can be notified anytime I drop new lesson. Thank you.
This is another example on trigonometry of right-angled triangle. You are given that tan theta is equal to 5/12, and you are asked to draw the right-angled triangle. We know that the trigonometric ratio for tan is TOA. And TOA means tangent is equal to the ratio of opposite to adjacent. Tangent equals to opposite over adjacent. So that we are given tan theta as equals to 5/12. This is depicting that opposite is 5 and adjacent of angle theta is 12. So that makes it easy for me to draw the right-angled triangle. I am choosing to draw mine this way. This is my right angle, which is the square corner angle. I want to pick this as my angle theta. This side is the opposite of angle theta, the side facing it. And from here, I can see the opposite is 5. That is settled. This is the side on which angle theta appear to be sitting upon, and that is my adjacent. And from here, I have seen that adjacent is equal to 12. That is 5/12. Tan theta is opposite over adjacent. I don't have any information about the hypotenuse, so I am leaving it empty. So the first question that is asking me to draw the right-angled triangle is settled. This is the right-angled triangle. The second question is asking me to find the hypotenuse of this right-angled triangle. In that case, I am dealing with the comparison of the three sides of this right-angled triangle, and I'm going to be employing Pythagorean theorem here. Pythagorean theorem says that hypotenuse square equals to opposite square plus adjacent square. The hypotenuse here, I don't know, so I want to call it x. That means I have s square equals to opposite square plus adjacent square. That is s square equals to 25, which is 5 times 5, and 12 times 12, which is 144. S square is equals to 25 plus 144 is 169. For me to get my x, I take square root of both hand sides. Taking square root of both hand sides, square root is the opposite of square. So both of them cancels out, and I have x equals to square root of 169, which is 13. That means hypotenuse of that right angle triangle is 13 units, depending on the units. The third question I am asked to find here is to evaluate sine theta and cos theta. This is a lot easier now that we know the hypotenuse. So I am going to find sine theta first. Roman figure 1. Sine theta, that is so. The trigonometric ratio so. The trigonometric ratio so says sine equals to opposite over hypotenuse. So sine theta here is going to be opposite, which is 5, and hypotenuse, which is 13. So that is 5 over 13. That is sine theta. The second question on part 6 says we should find cosine theta. Cos theta is the trigonometric ratio cap, which says cosine is equal to adjacent over hypotenuse. So cosine theta here is going to give us adjacent, we are saying is 12, and hypotenuse is 13. So cosine theta is equal to 12 over 13. And voila! We are done with solving this third problem. And this is where I'm going to be calling it a wrap on the lesson of trigonometry of right angle triangle.
Thank you for learning mathematics with Moni today. Do you know you are free to share my videos with your classmates, your colleagues, your friends, your cousins? Do that right now and be a blessing to them and to me.